In this video, we begin our next review topic, which is that of an indefinite integral, and the discussion really begins with antiderivatives. So we call big F an antiderivative of little f if the derivative of big F is little f. So it's undoing a derivative, so we call it an antiderivative. If we take the family of functions big F of x and we add on to it plus c, where we call c is any constant we want, that is called the most general antiderivative of f. So for example, x to the fourth is the antiderivative of 4x cubed. You can easily check that. By the power rule, you get the derivative. So x to the fourth plus c is the general antiderivative of 4x cubed. Now, notationally, antiderivatives by themselves can be a bit tough to work with, so we introduce the idea of an indefinite integral. So if big F is an antiderivative of little f, we use the following notation. We say the integral of little f is big F plus c. That is to say that this integral sign, which we refer to as an indefinite integral, represents the general antiderivative of little f. And kind of just a small bit of terminology, we call little f the integrand. So a few basic properties. First, we can undo the power rule of differentiation. So the indefinite integral of x to the n, 1 over n plus 1, x to the n plus 1, and plus c. And this is true for any number n which is not equal to 1, because we don't like to divide by 0. Also, the antiderivative or indefinite integral of sine is minus cosine plus c. The indefinite integral of cosine is sine plus c. And I'll remind you in a moment here of how we can always remember that. You can pull constants outside of indefinite integrals, and you can, just like derivatives, break them up over addition and subtraction. So recall from a previous review video, we said in terms of remembering the derivatives of sine and cosine. We remember tangent is sine over cosine, so sine cosine. We write their opposites down. And when we go around this in the clockwise direction, that would be differentiation. So if you want anti-differentiation, you need to go around this in the counterclockwise direction. So the antiderivative of cosine, or indefinite integral, is sine. The indefinite integral of sine is going to be, if you come up here, minus cosine. So let's apply this to a few examples. So if we use these basic properties, and after a few examples you're probably going to just look at this and directly evaluate, but you can say that we break it up, pull out constants, break it up over addition. And note, even though we're breaking it up and pulling out constants, every integral that we have, we use good notation. We always write our dx's. That tells us where the integration stops, in a sense. And in future courses, maybe more difficult problems, it might tell us what variable we integrate with respect to. So now, taking care of each one of these individually. X squared, the power is 2, 2 plus 1 is 3. So 1/3 x cubed. For x, whether we write it down or not, that power is 1. 1 plus 1 is 2, so the antiderivative is 1/2 x squared, and we need a single plus c here. So simplifying a bit, we have x cubed plus 5/2 x squared plus c. Now, as a side note, can you check your solution? And the answer is absolutely. Remember, this is supposed to be the most general antiderivative. So in order to check our solution, we just need to see that the derivative of this quantity on the right is really the integrand function. So just for fun, let's double check. If we were to differentiate x cubed plus 5/2 x squared plus c, the power rule tells us 3x squared plus 5/2 times 2x, so 5x, and the derivative of a constant is 0. And note, 3x squared plus 5x is exactly our integrand function. So our work is correct. So let's do the same thing. Indefinite integral of x to the 4/3. So our power is 4/3, so we think 4/3 plus 1 is 7/3. So 1 over 7 thirds x to the 7 thirds plus c. And you could leave it in this form, but I always prefer to simplify those complex fractions. Dividing by a fraction is multiplying by its reciprocal. So this is simply 3/7 x to the 7 thirds plus c. And notice notationally what should be going on here. At each step, you're showing your equal signs. You have your dx's until you have integrated. And once you've integrated, you have a plus c for any remaining steps. So one more example. To evaluate this indefinite integral, notice that the 1 over x squared and the square root of x are not exactly in the form that we had in our previous formula. So as a reminder, the indefinite integral of x to the n is 1 over n plus 1 x to the n plus 1 plus c. So once we can get it in terms of x to a power, we're good to go. So let's just rewrite so that we have powers of x. So this would be x to the minus 2 plus x to the 1/2. And now that we've written this in terms of powers of x, we can just use our formula 2 times. Minus 2 plus 1 is minus 1. So we're going to have 1 over minus 1 x to the minus 1 plus 1/2 plus 1 is 3/2. So 1 over 3/2 x to the 3/2 plus c. And after you refresh yourselves on a few examples, you're probably going to skip this intermediate step and go to the following. You would say this is minus 1 over x plus dividing by a fraction is multiplying by its reciprocal, so 2/3 x to the 3/2 plus c.